Good evening, student. Welcome back to our institution, Zenith institution, a pioneer residential non-residential institution at Bankura. Our today's subject, physics. I am Chinmoy Sir from Zenith institution, and our today's topic from the previous continuation is the vector analysis. So let's start with the topic again, vector analysis. From our previous class, we have a concept about the representation of the vector. That is how we represent the vectors. That is, every vectors having a magnitude and has a unit vector. That is called unit vector. Now, if we have a point x, y, z, then very simple from our previous concept, that is, we represent the vector in coordinate space like that. It is O to A, that is x, A to B, that is y, and B to the final point x, y, z, that is z, that is a vector. So we have first x, then y, and then z. And the position vector xi hat plus yj hat plus z hat. And the magnitude of the vector is given by under root of x square plus y square plus z square. That is from the previous classes. Today we discuss about the addition of vectors, subtraction of vectors, and the resolution of vectors. Now, with the topic that is the addition of vectors. Let's start with the addition rules. Addition of vectors. In case of addition, there are two basic rules. One is the vector triangle law and another is the parallelogram law. So we first discuss about the triangle law. So basic triangle law like that. If you have two vectors, such as the end point of a vector and the starting point of a vector just coincide at a point like that. If you have a vectors and you have a vectors, suppose you have a PQ vector, the end point of the vectors, and the starting point, that is PR vector. Suppose this vector is A vector and this vector is B vector, then just try to understand the point. These two vectors are arranged such as the end point of the first vector meets the first point, the initial point of the second vector. Then the resultant vector defined as P to R, and if the resultant is C vector, then from triangle, very simple, the resultant vectors, that is C vector is equals to A vector plus B vector. It is a fundamental vector addition formula. Suppose you have two vector A is equals to, as an example, 2i hat plus 3j hat minus k hat, and you have B vector is equals to I plus j plus 2k hat. Then what is the resultant? Then the resultant is the vector sum of A and B, that is A plus B. It's a triangle where two sides of a triangle represents by the vector both in magnitude and direction. Then the third side in opposite sense, that is P to R in opposite sense, represent the resultant of the vector. So what is the resultant? Simple, the resultant is equals to 2 plus 1, 3i, 3 plus 1, 4j, 2 minus 1 plus k. And the magnitude of the resultant is equals to under root of 9 plus 16 plus 1, that's equals to root 26 unit. And the interesting point is here, in case of vector triangle flow, the mod of A is equals to root of R of 4 plus 9 plus 1, that is root 14 unit. Mod B is equals to root of R of 1 plus 1 plus 4, that is root 6 unit. So it's an important point for vector addition. Mod of A plus mod of B greater than mod of C, that is the basic triangle formula or triangular inequality. So we hold in case of vector addition formula for the triangles law. So repeat again, we have the resultant vector from triangle law. The resultant is the third side of the triangle. First two sides represented by the vector both in magnitude and direction. And we have an example to discuss this triangle law. And now we discuss about the another formulation for the vector addition, that is the another form of vector addition. It is the modified version of the triangle law, that is the parallelogram law. Okay. Now we have the next topic on addition of vectors, that is parallelogram. That is Samuel Chu. It is a modified version of the triangle. Suppose you have two vectors A and B, like that. Very interesting. The initial point of the two vectors meet at the same point. In case of triangle law, the initial point of one vector meet at the final point of another vector. But here, the initial point of the two vectors meet at the single point. And if theta is the angle between them, then if we draw a parallelogram like that, then if the parallelogram is, just here put it A, PQRS, then the diagonal P2R is the resultant. Why? Because if PSC vector is B, then QR vector is also B. And we have from triangle PQR, that is A vector plus B vector is equal to C vector. That is very simple, the triangle. Only the change is here. Here we consider a parallelogram. If two sides of a parallelogram, consecutive sides of a parallelogram represented by the vectors in both magnitude and direction, then the diagonal represent the resultant. If theta be the angle between them, then we can find out the value of this resultant vector from analytical method. Just draw a perpendicular from here. Suppose Rn is the perpendicular, theta is the angle. Now we have from triangle PRN, that is PR square is equals to PM square plus Rn square, where PM is equals to PQ plus Qn. Now very simple, PQ magnitude is small a, capital A, plus Qn. Qn magnitude is B cos theta, because Qn is B cos theta. And Rn equals to B sin theta. So you have three fundamental equations. 1, 2 and 3. Just square this Pn and Rn and put here. So Pr square, that is C square, is equals to A plus B cos theta per whole square plus B sin theta per square. That's equals to A square plus B square plus 2AB cos theta. That is C square. So, from the next board, the resultant vector magnitude C is equals to A square plus B square plus 2AB cos theta to the power half. The important point here is the angle. When you put the angle between two vectors, then both the vectors are either divergent or both are convergent. That is the important part. Okay, so it is the magnitude resultant vector. And we have to find out the direction also, as the vector having a magnitude and direction both. Let this direction phi. The angle phi can be measured. Very simple. The direction can be measured. Very simple. Phi with A vector. That means tan of phi is equals to Rn by Phi. That means B sin theta from here, Rn, and Phi is the A plus B cos theta. So the direction is tan inverse B sin theta divided by A plus B cos theta. So most important equation is the resultant and its direction. The important argument from this discussion we have, that is the vector addition formula is simply commutative. That is A plus B is equals to B plus A. Number 2, it is distributive. A plus B plus C is equals to A plus B plus C. And third one, the maximum resultant for theta equals to 0 degree when the vectors are in same direction, that is A square plus B square plus 2AB. So maximum resultant is equals to A plus B is maximum, and minimum resultant when theta is equals to 180 degree, that is cos phi is -1. So C minimum is equals to A difference B. If A greater than B, then C minimum is equals to A minus B. So take a glance. First, the parallelogram law is a modified version of the triangle law. In case of triangle law, the end of one vector meets the initial point of another vector. But here, the two vectors A and B both are in divergent manner. The theta is the angle between them, and the resultant is the simple C vector, where C vector is equals to A vector plus B vector is the form of triangle. And we can find out the magnitude of the resultant vector from analytical method, that is C is equals to A squared plus B squared plus 2AB cos theta to the power half. And having a direction phi, that is with the horizontal or A vector, that is phi equals to tan inverse B sin theta divided by A plus B cos theta. And three important arguments from the result, that is this law is commutative, it is distributive, and the maximum resultant is C is equals to A plus B, where the minimum resultant is C is equals to A difference B. Now we discuss the another point from this parallelogram. Okay. Now we discuss some basic problems from vector analysis. That is, today's topic is the vector addition. So our first problem is here from triangle. If you have 2 points having coordinate P 3, 2, 1 and Q 1, 3, minus 2, then find out the PQ vector. Okay, how can we solve it? This problem, that is a vector in between 2 points. Generally, we represent the vector with respect to origin. But in case of this type of vector presentation in between 2 points, suppose you have the figure that is x, y and z is origin. Suppose you have 2 points, P point 3, 2, 1 and Q point 1, 3, minus 2. Okay. So you have 2 vectors. One is the OP vector and another is the OQ vector. Just look at the board. That is, first vector is OP and second vector is OQ. Then what is the resultant? That is, we can draw the line from P to Q. Now we have a triangle here. That is, from triangle OPQ, we have from triangle OP vector plus PQ vector is equals to OQ vector, where OP is the fundamental vector, that is 3i plus 2j plus k, and OQ is another vector, that is I plus 3j minus 2k. That is, first point is 3, 2, 1 and second point is 1, 3, minus 2. Then we have to find out the PQ vector. That is simple. PQ vector is equals to OQ vector minus OP vector. So what is OQ vector? That is 1 minus 3 I cap plus 3 minus 2 j cap plus of minus 2 minus 1 k cap. That is very simple. PQ vector is equals to minus 2i plus j minus 3k. That is, from P point to Q point, the P point is initial point and Q point is final point. That is, from P point to Q point vector, just put the difference from Q to P. That is 1 minus 3 minus 2, 3 minus 2, 1, minus 2 minus 1 is minus 3 k. And the magnitude of PQ, that is under root of 4 plus 1 plus 9, that is root 14 unit. If we change the direction from PQ to QP, just QP vector is here, that is 2i minus j plus 3k. That is, PQ vector and QP vector are in opposite direction. That is called the opposite vector. PQ is equals to minus QP, but QP mod is equals to PQ. That is a fundamental problem which defines the vector in between 2 points. Another problem about this discussion that also confirm the parallelogram law. That is very simply problem. Suppose C vector is A vector plus B vector and C is equals to A plus B. Then find out the angle between A and B. How can we find out? Okay, let's start with the problem. As C vector is A plus B, that means C is the resultant of A and B. So, C vector is equals to A vector plus B vector. That means, suppose A is a vector, B is a vector, then it is the resultant. That is, A is a vector, B is a vector, theta is the angle, C is the resultant. Then from parallelogram law, C is equals to A square plus B square plus 2AB cos theta to the power half. Also, C square is equals to A square plus B square plus 2AB cos theta. As C is equals to A plus B, squaring both sides, we have C square is equals to A square plus B square plus 2AB. Equation 2. Just subtract this equation 1 and 2. We have 2AB, 1 minus 2, cos theta minus 1 is equals to 0, as 2AB not equals to 0, so cos theta equals to 1, so theta equals to 0 degree, general value will be different. But very simply it is 0 degree. That is when two vectors are in same direction, then the resultant vector is the sum of the magnitude. These two problems from the vector addition, first problem define the vectors in between two points, and the second problem define a typical problem where two vectors sum is equals to the magnitude sum, then the angle between the two vectors. Just do the problem. Now I have a problem for you for my next class. We have C vector is equals to A plus B. If B vector get reversed, then D vector is equals to A minus B. So that C square plus D square is equals to 2 into A square plus B square. That is a very simple problem for you. Just C is A plus B. If B vector is get reversed, then D vector is A minus B. Then so that C square plus D square is equals to 2 into A square plus B square. So we are for the next problem.